This is figure 11 methods, and it's finding the coordinates and type of stationary points. In the second example is a quartic. X to the power of 4 divided by 4 minus 2x to the power of 3 divided by 3 plus 2. Stationary points occur when the derivative is equal to 0, because that's when the gradient is 0. So I'll take the derivative, f dash of x will equal 4 comes down, x to the power of 3 over 4, minus 2 times 3, x to the power of 2 over 3, and the derivative of 2 is 0. 4 cancels with 4, 3 cancels with 3, to leave x cubed minus 2x squared. And if I set that equal to 0, I can find when the gradient is equal to 0. If I factorise that, x squared comes out as a common factor, x minus 2. Therefore, there are 2 times when the derivative is equal to 0. When x equals 0 or when x equals 2. So I've got a stationary point at 0 and some value of y, and I have a stationary point at 2 and some value of y. I'd like to find those values of y so that I can find the coordinate of the stationary points. F of 0 is going to equal 2. F of 2 is going to equal 2 to the power of 4 over 4 minus 2 times 2 to the power of 3 over 3 plus 2. 16 on 4 minus 16 on 3 plus 2. 4 plus 2 is 6. 6 minus 16 on 3 is equal to 18 minus 16 on 3 equals 2 thirds. So my second stationary point is at 2 and 2 thirds. Okay, so I know that I have 2 stationary points at 0 and at 2, and I know from the function this is the derivative. I'd like to find out what the gradient is to the left of 0, between 0 and 2, and greater than 2, to know what type of gradients are either side of the stationary point, so I can work out what type of stationary point it is. Okay, when x equals negative 1, then f dash of negative 1 will be positive. Negative 1 minus 2 is negative, so it's going to be a negative answer, so it's going to look like that. I'm not interested in the value, I only want to know about the sign. In between here I can say x equals 1, so f dash of 1 squared will be positive, 1 minus 2 is negative, so that's also going to be negative. And the value greater than 2, for instance 3, f dash of 3 equals 3 squared is 9, which is positive, 3 minus 2 is positive, positive times positive is positive, so it's going to look like that. I can see that I'm going to have a curve like that, so I've got a stationary point of inflection and I've got a local minimum. Therefore, 0 and 2 is a stationary point of inflection, and 2 and 2 thirds is a local minimum. And they're the coordinates and the type of stationary points for that quartic.